It is the carryover of the previous class. We know that as the charged particle enter into the magnetic field with a linear velocity, it changes the linear motion into circular motion. The linear motion into circular motion like this for the positive charge, and for the negative charge it is like this, linear into circular motion like this. This is an account of magnetic force acting on the charged particle. That magnetic force is also known as Lorentz magnetic force. Look at this. This is Lorentz magnetic force, as it was invented by the Lorentz. And in this activity, it is actually a change of the magnetic force into a centripetal force. It is a change of magnetic force into a centripetal force. Centripetal force is the one which keeps the object revolving in the circular motion. Centripetal force. The magnitude of the force is given by this equation. This equation is a vector form, and also given by the equation, this equation is a scalar form. Here the magnitude of force is depends on theta as well. What is theta? The angle between the two vectors, that is velocity vector and field vector. And velocity vector and field vector. Let us see that the conditions when the particle enters the magnetic field in the same direction. If the particle enters the magnetic field in the same direction, that is velocity vectors are, and V and B are in the parallel direction. It means theta equals 0. Theta equals means sin 0 equals 0. The force becomes 0. Force is 0. So magnetic force is 0, and in that case no magnetic force act on the charge and no such revolution we realize. In the other condition, if the particle enters the magnetic field in the direction opposite to it, that is anti-parallel, in that case also the theta is set to be 180 degree anti-parallel. If you write theta equals 180 degree, sin 180 is also 0. 0 into this is 0. Fm is 0. In that case also magnetic force is 0. If the particle enters the magnetic field in the direction perpendicular to it, that is V and B are perpendicular direction. If the particle enters the field in the direction perpendicular to magnetic field, then they will see that magnetic force we get, that is a maximum force, you realize. The maximum force is given by Q into V into B, the equation. So when the particle enters the field in the direction perpendicular to it, this is the expression we get. That is the definition, or the magnitude of the force is given by Q into V into B, maximum force. So this magnetic force, what I say, Lorentz magnetic force, it is changed into centripetal force. The centripetal force and centrifugal force are balancing. In any revolution, what is that? Any object is revolving in circular motion. In such cases, there are two forces are acting in opposite each other. One is centripetal force, other is centrifugal force. Centripetal force is acting towards the center of the circle. Centrifugal force is acting away from the center. That is the direction. Centrifugal force is always what is that? Pull this object away from the center. Centripetal force tries to pull the object to the center. That is the difference. If they are balanced, then the object is keep rotating in the circular motion. If that is the case, the centripetal force or centrifugal force is given by this equation or defined by this equation. That is, equation is mE squared by r. So m stands for mass of the object, mass of the charge which is revolving, and v is the velocity or speed similar to the linear velocity with which it is moving in the circular motion. And r is the radius of the circle in which it is revolving. R is the radius of the circle. So both centripetal force and centrifugal force are equal to this mE square by r. It is defined by this. So now in this activity, this magnetic force what I said is exactly equal to centripetal force. It is just a change of Lorentz magnetic force into centrifugal force. If that is the case, these two forces are equal, the same direction. That is the direction towards the center. Then you have to substitute for this. Already know what is the definition for this here given for a maximum value, that is Q into V into P, and the definition for this is mE square by r. So equate them. There's the equation we get it. From this equation we get this equation like this. What is the equation known as? This equation for radius of the circle. Circle means the particle revolving in the circle like this. Radius of the circle. So this radius of the circle is a function of all these quantities. Look at this function is what are the functions? Radius. So radius of the circle is directly what is that depends on m and v, mass of the particle and velocity or speed of the particle. If these are higher values, we have higher value of radius. So higher these values and larger the circular motion. Radius higher circle. And inversely related to Q and V. That means higher the values of Q and V, here lower the value of R. If these values are higher, it is circulating in what is smaller circular, that is smaller circular revolution. We get this. That is what we understood from this equation. And with this equation, you go for writing other important equations. And when a particle or object is revolving in a circular motion, any object, maybe micro or macro. If it is micro means it may carry charge or negative charge or neutral charge. That particle, revolving particle, is characterized by the following properties. Any revolving, what is that? Here revolving is for a charge. By these properties are, one is that is omega, it is known as angular velocity. And one more term or properties, time period of revolution. And one more term, F, frequency of revolution. Let us understand the meaning of this angular velocity. What is meant by angular velocity? Angular velocity is given by the mathematical equation. Look at this equation. Angular velocity d theta by dt. It means rate of change of angle with time. rate of change of angle with time. In revolution, the angle change. What is the linear velocity? It is the rate of change of distance with time. Where you define V equals dl by dt. V equals dl by dt. Linear velocity. Here angular velocity is d theta by dt. It means that is what angle the particle revolve through per unit of time. That is called as angular velocity. To what angle it is revolved in unit time. That is theta is the angle of revolution. Says that that is called as angular velocity. So just to understand a new illustration of this angular velocity, as you know, when this particle is revolving through one complete rotation, you know that this circle, what is that, how many degrees for one complete revolution? That is 360 degree. Starting from here, the angle 1, 2, 3, 4, totally here 180, then 180 again 360 degree. For one complete rotation, the total angle cover is 360 degree. If the particles take 10 seconds to complete one revolution, 10 seconds, what would be the angular velocity? Substitute for this. Total angle for one revolution is 360 degree and the total time taken is 10 seconds. 360 by 10 is 36 degrees per second. 36 degrees per second. That is called as angular velocity in terms of degree. And also we can express the angular velocity in terms of radians. What is radians? 360 degree in radians. 360 degree equals 2 pi radians. 360 equals 2 pi radians. So in 10 seconds one revolution takes place, and for completion of one revolution 2 pi radians coverage. 2 pi divided by 10. So when you divide 2 pi divided by 10, 0.2 pi radians you get. 0.2 pi radians. That is called as angular velocity. It is just an illustration of understanding the angular velocity. The angular velocity can also be defined in terms of linear velocity v. It is defined by this equation. Look at this. Angular velocity is equal to v divided by r. R stands for, what is that? Radius of the circle. V divided by r. So in this case equation, we know what is that equation for r. Substitute for r. R is this. Substitute and simplify. That is v divided by r is me by qb. That will qb go to q into v goes to numerator, v cancel, denominator only m remains. Look at the final equation. Is omega equals q, b and m. So is a function of omega is a function of all these quantities. If you know these quantities, we can calculate what is omega and the velocity of the particle moving in the magnetic field. Similarly, we have the definition for time period of revolution. What is meant by time period of revolution? It is just a time taken for completion of one revolution. Time taken for completion of one revolution. If it is 10 seconds, time period is 10 seconds. Complete time taken to complete that is to complete one revolution, we call time period of revolution. It is defined by this mathematical equation 2 pi by omega, because t and omega is related like this. You know the equation for omega. Substitute for omega and simplify, we get this equation. Look at this equation. In terms of the again the same quantities M, Q, B. If you know these quantities, time period of that revolution also be calculated. This is another equation. And one more final equation, F equals 1 by T. It is defined by what is frequency of revolution. Frequency of revolution in unit time, that is in unit time, how many revolutions take place? In 1 second, if there are 5 revolutions take place, 5 times it is what is not revolved. It is called 5 per second frequency revolution. How many times the charge is revolving in circular motion? In 1 second is called frequency of revolution. This frequency of revolution is given by 1 by T. What is T? Time period. Substitute for T. 2 pi m divided by qb, and simplify, get qb divided by 2 pi m. Look at the frequency of the revolution is given by this mathematical equation. Look at this, all these mathematical equations. The angular velocity, time period and frequency of revolution all depends on is a function of mainly q, b and m. Here q, b, m. 2 pi is a constant. And q, b divided by m. 2 pi is a constant. If you know q, b and m, we can calculate what is the value of omega, what is the value of t, and what is the value of frequency of this revolving charge in the magnetic field. These are important for the calculation of problems. With this, we have completed this.